So in this video, we're going to talk about the idea of naming alkanes. So how do we name alkanes? So the basic idea of naming alkanes can be summarized as we have a prefix, a locant, a parent, and we have a suffix. Now, the locant tells us pretty much where is the primary functional group. So where is the, I'm just going to write 1, 0 as primary. So where is the primary functional group? Whereas the suffix actually tells us what is the primary functional group. What is the primary functional group? Now, the parent, right? Now, the prefix, or let me talk about the prefix. The prefix tells us essentially where and what, right? So where and what are these substituents? So substituents just mean like any branching, right? So again, the prefix tells us where and what are the substituents. Now, the parent tells us how many carbons there are. How many carbons there are. And so this is the idea of naming alkanes. Now, before we actually go to some examples, we need to be comfortable with the different alkanes. Right? So it's one of the first things you'll learn in organic chemistry. So if we have a CH4, this is what we call methane. If we have a CH3, this is what we call ethane. If we have a CH3, CH2, and all I'm doing at this point is just extending the carbon chain by 1, this is what we call propane. If I have a CH3, CH2, CH2, CH3, this is what we call butane, right? So all I'm doing is extending the carbon chain by 1, and it goes from methane to ethane to propane to butane. If I go one step further and go CH3, CH2, 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 CH3, this is what we call pentane. And we go all the way further for organic chemistry 1 especially, you're responsible for memorizing up to about decane. Right? So if we go 6 carbons, 2, 3, 4, 5, 6, this is what we call hexane. And you could imagine if we go one more, it would be called heptane for 7 carbons. 2, 3, 4, 5, 6, 7. So this will be called heptane. Alright, if I go one more, 2, 3, 4, 5, 6, 7, 8, this is what we call octane. If I go one more, 2, 3, 4, 5, 6, 7, 8, 9, this is what we call nonane. And if we go to the last one, which is 2, 3, 4, 5, 6, 7, 8, 9, 10, this is what we call decane. So those are the alkanes that you're responsible for memorizing. Now let's go over the systematic representation of how we actually name alkanes, and then we do some examples. So the first thing we want to do is identify the parent. And the parent is simply the longest continuous carbon chain. Right, so this word continuous is really important, and we're going to talk about it in some examples. Right, so the parent is the longest continuous carbon chain. The second thing after we identify parent, we want to number the atoms. So you want to number the atoms in the parent. Right? So we want to number the atoms in the parent as the second thing that we want to do. Now, numbering, we have to be specific. So this just means beginning. So we want to number beginning at the end, nearest. So we want to number beginning and end nearest to the first branch of the parent. So nearest to the first branch of the parent. Right? So when we say number the atoms in parent, we must start beginning with nearest branch of the parent. Right? And we're going to do that in an example to kind of illustrate what we mean. Now, the third thing we want to do is then identify the substituents. Right? And we say the substituents are just, again, any part or any group, essentially, not part of the parent chain. Right? So that's what the substituents are. Now, under the substituents, we got to be specific. What we're saying is that we're going to assign a number. We're going to assign a number, or in other words, a locant, to locate its point of attachment. Right? That's what we mean, to locate its point of attachment. We must also specify that if two substituents, so be careful now, if two substituents are on the same carbon, then we must give both numbers. In other words, if two substituents are on the same carbons, we must give both numbers and separate with a comma. Right? And the last thing we want to do as number 4 is write the name as a single word with no spaces. So write the name as a single word with no spaces. Right? Now, under this, we must be able to specify that we actually use hyphens. And so we use hyphens to separate locants or numbers, locants and substitutions. Right? Now, if we have more than one substitution, right? So if more than one substituents, or locants and substituents. So that's what I meant, not substitutions, but substituents. So if you have more than one substituents, then list in alphabetical order. All right. The last thing we must specify is that if there is one more substituent, if we have more than one substituents of the same identity, then we must use di, tri, and tetra, etc. Right? So if more than one substituent we use, so if there's one, if there's more than one substituents of the same identity, all right, so it's important that we say of the same identity. Then we're going to use di, tri, tetra, etc. Right? So if we have more than one substitution of the same identity, we use di, tri, tetra, etc. So let's do some examples. Let's say you're given this compound. How would you name it? Well, the first thing I'm going to do is to identify the parent, and that is the longest continuous carbon chain, right? So the parent in this case would be, okay, well, I'm going to count. I have 1, 2, 3, 4, right? If I start counting from here, I have 1, 2, 3, 4. Still gives me 4 carbons. So 4 carbons is the longest continuous chain, and that corresponds to butane. Now, what are the substituents, right? In this case, I only have a methyl group, and now remember, I could start counting from here, or I could start counting from here. However, the rule says that in our little soliloquy that we went on, says that we start counting from the point that has the from the parent chain. We start counting on from the parent chain that is closest to the first branch point, right? So in this case, we must start from here. So in this case, if this is carbon 1, then this must be carbon 2. So on carbon 2, we have a methyl group. So this would be 2-methyl. Now in this case, there isn't anything else we need to do. So we just put our findings together. So this becomes 2-methyl or 2-methyl using our hyphen butane. So that is the name for this compound. Let's try a more difficult one. How will we classify this compound? Well, what's its name? Well, the first thing I'm going to do is identify the parent. And the parent is the longest continuous carbon chain. Now, what I like to do is to number my carbons. Right? In the first example, it was pretty much a short list. Pretty much it was a short amount of carbon, so we didn't really need to number. Again, for problems like this where the carbon chain is really long, I want to start numbering. Right? Now, if I say this is carbon 1, then this is 2, 3, 4, 5, 6, 7, 8. Now, I could also start from this end, right? And so this would be 1, 2, 3, 4, 5, 6. I'll get 7. 8 is greater than 7, so therefore the parent would not be considered heptane. If I also go to here, it still would be 7, and so I cannot count starting from this end. If I start from this end, 1, 2, 3, 4, 5, 6, 7, 8, or I could get 8 here as well. Here's the problem with that. My first branch point comes at, so this is carbon 1, this is 2, this is 3, right? So my first branch point comes at carbon 3, whereas if I started from here like I did initially, my first branch point comes at carbon 2. So this is the reason why you would start naming from this end. So getting that out of the way, we notice that our parent is octane. Now, what are the substituents? We just said on carbon 2, we have a methyl group. So let's write our substituents. Carbon 2, we have a methyl group. So this is 2-methyl, 2-methyl. Do we have any other substituents? Well, on carbon 6, we also have a methyl group. So this is 6-methyl. We don't seem to have any more substitutions, so putting everything together, starting with the numbers, since it's the same substituent, we're going to say 2, 6 dash, because we have 2-methyl group as a substituent, we're going to say dimethyl octane. And this is how we would name this compound. How about this one? Right? How would we name this compound? Well, I'm going to start with the parent, right? So in this case, what is the parent? The parent is 1, 2, 3, 4, 5, 6, right? If I start counting from here, I'm not going to get more than 6. If I start counting from here, 1, 2, 3, 4, 5, 6, I do get 6. So it really doesn't matter if I count from starting from here or here. I still get 6. And again, my branch point is at carbon 2. Right? So in this case, we know our parent is going to be hexane since it's 6 carbons. The substituents, right? On carbon 2, I have a methyl, so this is 2-methyl. On carbon 3, I have a methyl, so this is 3-methyl. Okay? So in this case, putting everything together, we're going to put our numbers first. Okay? So this should be 2/3-dimethyl, since we have 2 methyl groups, hexane. Let's go to a bit more complicated one. How would we name this one? How do we name this compound? Well, I'm going to start to find the parent. So the longest carbon chain, in this case, I could start from here. So this is 1, 2, 3, 4, 5, 6, 7, 8, right? Is the parent octane? Well, if I start from anywhere else, if I start from here, right? So if I start from here as carbon 1, right? Or even here as carbon 1, it's still the same as starting from here as carbon 1. Right? So it doesn't matter if I start at any of these 3 places, my first branch point is still going to be on the second carbon. This also gives me the longest parent chain, the continuous longest parent chain, which would be octane. If I start from here, this will not give me octane, right? Because this would be, okay, well, 1, 2, 3, 4, 5, 6, 7. I would get only heptane, right? Octane beats out octane beats out heptane, so the parent would be heptane. If we go in this direction, 1, 2, 3, 4, 5, 6, now I get hexane. It's even worse. So the parent in this case would actually be octane. Now, what are the substituents? Well, on carbon 2, we have 2 methyl groups. Now remember, based on the rules above, we said that if 2 substituents are on the same carbon, we both give each a name and they both get their number. So in this case, it'll actually be 2,2-dimethyl. right? We both give them numbers and we both give them names. In this case, there are two methyl groups, so we just combine and we put our prefix dimethyl. We also see that on carbon 4, we actually have ethyl, so we have 4-ethyl. We don't seem to have any more substituents, so putting the name together, remember now, be careful. We must be in alphabetical order. Right? So we must be in alphabetical. We must be in alphabetical order. Now, the alphabet doesn't pertain to whether we use the prefix di, tri. What we're really looking at is the actual parent name, the actual substituent, whether it's methyl or ethyl or propyl, right? So the di, even though we had a di in it, or even if it was like 3 carbons and we had tri, it doesn't pertain to the alphabetical order. It doesn't pertain to the alphabetical order. So in this case, we ignore the di and we use M and E for comparison. Now, because E comes before in the alphabet, comes before M in the alphabet, we would name this as 4-ethyl hyphen 2,2-dimethyl octane. So be careful. Remember, even though D comes before E, di, the prefixes that we put in there to summarize the methyl groups, do not contribute to whether or decision to put stuff in alphabetical order. Let's try one more of these that to kind of solidify our knowledge. What if you're given this one? How do we name this? Well, again, I'm going to do whatever we've been doing along. So what is the parent? Longest continuous carbon chain. Well, I could start from here as 1, but I'm not going to do it. I'm actually going to start as here as 1. Why? Because on carbon 1 on this side, and let me erase this. On carbon 1 on this side, I have the bromine. So the bromine comes first, counting from the right-hand side versus the left-hand side where my first substituent doesn't come until carbon 3. Right? So in this case, it will be 1, 2, 3, 4, 5, 6, 7. So I know my parent in this case would be heptane. Now, what are the substituents? Well, on the first carbon, on carbon number 1, I have a bromine. So this would be 1-bromo. Right? And when we're naming substituents, especially for the halogens, we just drop the ene and we add an O at the end. So bromo, chloro, iodo, etc. Right? On carbon 4, we also have a chlorine. So this would be 4-chloro. And carbon 5, I have a methyl group. So this would be 5-methyl. Now, we don't seem to have any more substituents, so let's put the name together. Careful, we're using alphabetical order. So in this case, bromo must come first in the name. Right? So this would be 1-bromo dash 4-chloro, since C comes before M in the alphabet, dash 5-methyl heptane. Right? So you do not space the methyl heptane, right? It's all combined together. And this would be the name for this compound. Right? And ladies and gentlemen, this is how we actually name alkanes.